This is lesson 8.3a, where we're going to introduce what a logarithm is. So in class we did an activity that helped us use a table of values using bases and exponents. And what you need to know for this lesson is that we found three types of equations that have exponents in them. We have equations like 3 squared equals x. We have x squared equals 9. And then we have 3x equals 81. And the difference is that we'll notice that this one has the x as kind of the answer, if you will. This one has x as the base, and then this one has x as the exponent here. So these are all the different places that you can have an unknown value. Now we said the first one, well, that's not so bad. You just type it into your calculator, or you just know it. You can figure that out. It's something raised to a power equals x. We said for the second one here, if it's a base, you have to undo the power. So we said, well, we'll do a square root, or maybe a cubed root, or a fourth root, or a whatever root to get the x by itself. So for example, take the square root of both sides. X would be plus or minus 3. We said, but for this one, we don't have any good way to find this except for guess and check. And while guess and check can get us there, it's not a method. It's not something tried and true that we know works every time. We know that when something's squared, we take a square root. We know that when something's multiplied, we divide. So what's our method for this type here? Well, our method is that in math, we created something called a logarithm. And a logarithm, which we abbreviate just by saying a log, is when you take an equation like 5 to the x equals 78,125, and you say x equals log base 5, 78,125. So it is a way that converts from getting the x in the exponent to getting the x by itself on the outside. In the same way that if you have x squared equals 9, you would use a square root of both sides, and it would give you x equals square root of 9. It would get the x by itself. Okay, it's the same method here. So in English, it's important that you can say what a log is, and it's the same in English for both of these statements. We say 5 to what power is 78,125. Now that's easy to see when you see it here because that's exactly what it looks like. 5 to what power is 78,125? In log form, you kind of think backwards almost. You think 5 to what power is 78,125? So 5 to what power is this? So this answer here is always going to be the exponent, if you will, because that's what it was over here. It's the exponent. So your answer to a log will always be an exponent. This here will always be the base. We'll talk more about this on your next page as well. Let's take a look at what this might look like with some smaller numbers that you're more familiar with. So in English, this one is asking us 5 to what power is 125. And again, the what power part is this. So 5 to the third. So x equals 3. 5 to the third power would be 125. Let's try another one. Log base 2 of 8. So I'm asking 2 to what power is 8? And we know that 2 to the third power is 8. So this one here, this log, equals 3. So in formal language, what we're doing right here is we're converting something in exponent form to something in log form over here. And this conversion goes both ways. You can go from exponent to log or from log back to exponent. So this base will be log base b of y equals x. Now this b is a subscript, so it should be written beneath like the normal line. It should be written down there, whereas the y is on the normal level. So in English, or if I'm speaking math, I will often say log base b of y is x. That's how I'll speak this. Notice a couple things. Your exponent is the answer to your log problem. So this guy here was the exponent. And notice that your base, b, is the same base in your log. So they always share the same base. So if that's an 8, this will be an 8. If it's a 5, it'll be a 5. We're going to practice just doing this conversion back and forth a couple times. So write each equation in logarithmic form. Focus in on your base for each one of these. So if this is our base, then we will have log base 3 of 729 equals 6. This is saying 3 to the 6th power is 729. That's what this is saying for both of these, for this one and for this one. Next one, log base 2 of 32 equals 5. 2 to the 5th power is 32. Even if your base is written on the other side, that's okay. You're saying 2 equals log base 7 of 49, or 7 to the 2nd power is 49. So now let's practice seeing what different logs are worth. When it says to evaluate each logarithm, it's asking for the value of each log, or the worth of each log. So this one is saying 3 to what xth power is 27? Well, 3 to the 3rd power, so x equals 3. 9 to what power is 81? 9 to the 2nd. 2 to what power is 16? So 2 to the 4th. And 6 to what power is 216? Now again, it might take you a couple seconds to kind of count that on your hands or use your calculator, but we're asking for the powers. There are two special types of logs. One is the common log, right here, and then the other is the natural log. We're not going to see much of the natural log today, but I want you to just know it exists. So the common log is anytime you have a log with a base of 10, and then it doesn't matter whatever that number is there. But this can be written as log, and you actually don't write the base. If there is no base written, you assume it's base 10. So this down here is a common log, log 100. Natural log is when you have log base e, and then again some whatever stuff you have here. And this is written as the ln of whatever that stuff is. So whenever you see ln, think of it as the natural log. I think log natural. It just helps me remember, but the natural log has a base e. Let's look at some common logs. Here's one where, again, we would assume the base is 10. So it's saying 10 to what power is 100? 10 to the 2nd. So this log is worth 2. 10 to what power is 10,000? 10 to the 4th. So this log is worth 4. Now this one, 10 to what power is 1 over 10? This is where we have to think about our list here of log powers. So 10 squared is 100, 10 to the 1st is 10, 10 to the 0th is 1, remember anything to the 0th is 1, 10 to the negative 1 is 1 over 10. So this here is saying 10 to the negative 1 power is 1/10. Let me throw in another one here. Let's say we had log 1/1000th. This one is saying that 10 to what power is 1/1000th? 10 to the negative 3rd power. All right, let's review a little bit about inverses. Remember, an inverse swaps x and y, or swaps the domain and the range, and then you solve for the y value. So we're going to try finding inverses of logs. So if this is a log, what is its inverse? First thing you do is you swap the x and the y. So swap the x's and the y's here. And you leave everything else the same. So log base 3 equals, log base 3 of y equals x. Now, we like it when things are written with y equals. This is nice. So this was our original, set equal to y, check, we like it. This over here is the inverse, and we don't like that it's equal to x, we want it equal to y. So we want to solve for y. We're going to use our conversion. We're going to say that base can come over, so y equals 3 to an x. We're saying 3 to what power is y? So this is our inverse, and we like it that it's equal to y. Again, this is the original. It's equal to y, yay. The inverse is when we say log base 5 of, I did not switch them, did I? Whoops, quick. Log base 5 of y equals x. That's the inverse. Let's go ahead and solve for y. So the base can come over. Y equals 5 to what power? So that's the inverse here, and set equal to y. This is a page in your notes, page 20, which is a great page to practice after you have seen lesson 8.3a. So this page just takes you through practice of converting, so writing things in logs versus writing things in exponents, and it also helps you practice evaluating and the inverses. So I'm going to walk you through a couple of these just to help us practice these some more together. So first of all, writing things in log form or writing things in exponent form, remember that y equals b to the x is equivalent to log base b of y equals x. That's your conversion form. You do need to memorize this. You need to know that. So for our first one here, move the 3 over. So this is log base 3 of 81 equals 4. What I recommend is that you go through and you practice this, and then you come back and check your answers, because I'm going to run through these quickly and then talk about them. So you can hit pause on your video, try a couple on your own, and then come back and check. This one is log base 4 of 16 equals 2. Log base 2 of 8 equals 3. Log 1000 equals 3. Notice I didn't have to put the 10 because this is a common log, so I don't have to write it if I don't want to. And log base 5 of 125 equals 3. Going the other way, exponential form. This one would be 9 equals 3 squared. 4 equals 16 to the 1/2, and little star here next to 7, because that 1/2 power, what's happening to the 16? That's a square root. So if you don't remember that from our previous chapters, that's important. A 1/2 power is a square root. A 1/3 power would be a cubed root. 100 equals 10 squared. 64 equals 4 cubed. 125 equals 5 cubed. 36 equals 6 squared. Now again, for these ones, we're asking what is each log worth. So when you're evaluating, you're saying base to what power is the number on the inside. That's what we're asking ourselves. So 2 to what power is 16? 2 to the 4th. Nothing written, so it's a 10. 10 to what power is 1000? 10 to the 3rd. 6 to the 3rd power is 216. 7 to the 2nd power is 49. And now this one, 4 to the what power is 2. Again, this is a little weird. Little star here. And for this one as well. Think about a thought bubble. This is saying 4 to some x power is 2. Think about what we just saw up top. We saw that a 1/2 power is the same as the square root of 4. And so the square root of 4 would be 2. So this one is asking for a 1/2. Same thing here. 25 to the 1/2, so square root of 25 would be 5.